Welcome back to the fifth in our series of videos on functional dependencies and normalization. We just finished a video on functional dependencies, and now we're going to proceed to the introduction to normalization. Having introduced functional dependencies, we are now ready to use them to specify some aspects of the semantics of relation schemas. We assume that a set of functional dependencies is given for each relation and that each relation has a designated primary key. This information, combined with the tests or conditions for normal forms, drives the normalization process for relational schema design. Most practical relational design projects take on one of the following two approaches. The first approach: perform a conceptual schema design using a conceptual model such as an ER diagram and map the conceptual design into a set of relations. Or, approach number two, design the relations based on external knowledge derived from existing implementation of files or forms or reports. Following either of these approaches, it is then useful to evaluate the relations for goodness or quality and decompose them further as needed to achieve higher normal forms using normalization theory. That is in fact what normalization is. It is the decomposition of relations into smaller and smaller and more precise forms. This is called the normalization theory. We focus in on the first three normal forms of relation schemas and the intuition behind them, and discuss how they were first developed historically. The normalization process, as first proposed by Codd, 1972, takes a relation schema through a series of tests to certify whether it satisfies a certain normal form. The process, which proceeds in a top-down fashion by evaluating each relation against the criteria for normal forms and decomposing relations as necessary, can thus be considered as a relational design by analysis. Initially, Codd proposed three normal forms, which he called first, second, and third normal form. A stronger definition of third normal form, called Boyce-Codd normal form, was proposed later by Boyce and Codd. All these normal forms are based on a single analytical tool: the functional dependencies among attributes of a relation. Later, a fourth normal form and a fifth normal form were proposed based on the concepts of multi-valued dependencies and join dependencies, respectively. Normalization of data can be considered a process of analyzing the given relational schemas based on their functional dependencies and the primary keys to achieve the desirable properties of 1, minimizing redundancy, and 2, minimizing the insertion, deletion, and update anomalies. It can be considered a filtering or purification process to make the design have successively better quality. Unsatisfactory relation schemas that do not meet certain conditions, the normal form tests, are decomposed into smaller relation schemas that meet the tests and hence possess the desirable properties. Thus, the normalization procedure provides database designers with the following: a formal framework for analyzing relation schemas based on their keys and on the functional dependencies among those attributes. Also, a series of normal form tests that can be carried out on individual relation schemas so that the relational database can be normalized to any desired degree. The definition: the normal form of a relation refers to the highest normal form condition that it meets and therefore indicates the degree to which it has been normalized. Normal forms, when considered in isolation from other factors, do not guarantee a good database design. It is generally not sufficient to check separately that each relation schema in the database is, say, in Boyce-Codd normal form or third normal form. Rather, the process of normalization through decomposition must also confirm the existence of additional properties that the relational schemas taken together should possess. These would include two properties: the non-additive join or lossless join property, which guarantees that the spurious tuple generation problem does not occur with respect to the relation schemas created after decomposition. The dependency preservation property, which ensures that each functional dependency is represented in some individual relation resulting after decomposition. The non-additive join property is extremely critical and must be achieved at any cost, whereas the dependency preservation property, although desirable, is sometimes sacrificed. Most design projects acquire existing designs of databases from previous designs, designs in legacy models, or from existing files. Normalization is carried out in practice so that the resulting designs are of high quality and meet the desirable properties stated previously. You recall I mentioned that during the development of a new system, it was found that there were 5 student tables in the former system. This is an example of the fact that most design projects acquire existing designs of database from previous designs. Although several higher normal forms have been defined, such as fourth normal form, the practical utility of these normal forms becomes questionable when the constraints on which they are based are rare and hard to understand or detect by the database designers and users who must discover these constraints. Therefore, database design as practiced in the industry today pays particular attention to normalization only up to third normal form, possibly Boyce-Codd normal form, at the very most, fourth normal form. Another point worth noting is that database designers need not normalize to the highest possible normal form. Relations may be left in a lower normalization status, such as second normal form, for performance reasons. Doing so incurs the corresponding penalties of having to deal with anomalies. Another definition: denormalization is the process of storing the join of higher normal form relations as a base relation, which is in a lower normal form. Another definition: a superkey of a relation schema is a set of attributes with the property that no two tuples in any legal relation state will have the same value. A key is a superkey with the additional property that the removal of any attribute will cause it not to be a superkey anymore. If a relation schema has more than one key, each is called a candidate key. One of the candidate keys is arbitrarily designated to be the primary key, and the others are called secondary keys. In practical relational database, each relation schema must have a primary key. If no candidate key is known for a relation, the entire relation can be treated as a default superkey. Definition: an attribute of a relation schema is called a prime attribute if it is a member of some candidate key. An attribute is called non-prime if it is not a prime attribute. That is, if it is not a member of a candidate key. Well, I think this is a good place to take a break. We've been introduced now to normalization, and we'll proceed to more detailed discussion of normalization, beginning with first normal form in the next video. So, since we have been talking about normalization, why don't we make normalization our mystery word for this video? So go ahead and submit your mystery word. Check your knowledge on the material that we've covered in this video. And when you're ready, come on back and we will start our discussion of first normal form.